Look at a web page from 1996 and you see raw information. That text-only document can instantly be organized into a polished, highly interactive interface. This process splits the code into two distinct layers. The first is HTML, the structural skeleton and data. The second is CSS, or Cascading Style Sheets, the visual presentation layer responsible for the layout, typography, and color applied to that skeleton. Writing style rules directly inside an HTML file becomes impossible to manage when a site scales to hundreds or thousands of pages. To solve this, developers use external CSS, a method that isolates design rules in their own dedicated document. By extracting design logic into a single .css file, you update one line of code and see the change reflected across every page instantly. This connection is established through a link tag in the head of the HTML document. It tells the browser to fetch the global presentation rules defined in the CSS file on the right and apply them to the content. Maintaining this separation of concerns is what allows large codebases to remain clean, readable, and easy to scale. Every CSS rule is built from two atomic components: the property, which defines what attribute you are changing, and the value, which sets the specific style to apply. But before the browser can apply these styles, it needs to know which part of the HTML you are targeting. A tag selector targets every instance of an element type, turning every H1 blue globally. For targeted styling, use a class attribute. Adding a dot before a name applies rules to specific groups without affecting the rest of the page. The ID attribute is even more specific. Identified by a hash symbol, it is reserved for elements that appear only once on a page, such as a main header or a unique navigation bar. If a component appears multiple times, use a class. If it is a singular structural piece, use an ID. This selection system gives you surgical control over how specific parts of a complex web application are styled. This precision targeting leads to a common scenario: a single element being targeted by a tag, a class, and an ID simultaneously. If all three try to set a different background color, the browser has to choose which one wins. To resolve this, the browser uses specificity, a mathematical hierarchy that calculates the priority of every rule. This chart displays the browser's scoring system. At the base, the element selector carries the lowest weight. A class overrides an element with a higher score. An ID overpowers both. At the top, the important tag acts as a global override, ignoring the math entirely. While powerful, relying on important is considered an anti-pattern in professional development. Using it to force a style to work often leads to a cycle where every new rule needs its own important tag just to be seen, making the code nearly impossible to maintain. The 2025 standard solves this through Cascade Layers, or @layer. @layer allows you to group rules into distinct buckets. Instead of fighting over numerical scores, layers declared later in the code simply take priority over those declared earlier, keeping the organization clean. Professional CSS is about organizing rules within this cascade so they work together, rather than using brute force to get them to render. Beyond colors and text, CSS is the engine that dictates how physical layouts are calculated on your screen. The browser handles this through the box model, treating every HTML element as an invisible rectangular container. At the core of the model is the content area. Defining a square's width as 300 pixels reserves that space for the text inside. We can add padding to create internal space and a border to create a visible boundary around the outside. By default, CSS adds padding and borders to the outside of the content. Adding 40 pixels of padding and a 4-pixel border makes the total width 344 pixels, often causing it to awkwardly break out of its layout and shift other elements. To fix this, modern projects use a global reset called box sizing border box. This rule forces the padding and border to grow inward. The total width stays exactly at your declared 300 pixels, and the content area inside shrinks to make room. Setting border box at the start of a project ensures your layout math remains predictable as you build more complex designs. For a layout to work across different screen sizes, it must be responsive. For years, developers used media queries to check the width of the entire browser window and change the layout based on whether that window was desktop or mobile-sized. But in modern dashboards, an element might have plenty of room in a sidebar while being cramped in a main content area, regardless of how wide the browser window is. The 2025 standard introduces container queries to address this. Container queries allow an element to respond to the size of its parent container. If a container shrinks because another element is taking up more room, the items inside can automatically rearrange themselves, even if the browser window hasn't changed size. We also use logical properties, which swap physical directions like padding top for relational directions like padding block. These properties allow a layout to automatically mirror its spacing when the site is translated into a right-to-left reading language. This modular approach ensures that UI components are self-aware and adaptable, rather than being hard-coded for specific devices. CSS has transitioned from a basic text styling tool into a highly logical layout engine. Success in modern design requires isolating styles in external files, managing dimensions with the border box reset, and building components that adapt to their environment. The 2025 toolkit expands these capabilities with native CSS nesting, the has selector for targeting parent elements, and scroll-driven animations that function without any JavaScript. The syntax and box model rules we've covered today provide the essential foundation for these advanced systems. Over the next 13 chapters, we will use these principles to build two-dimensional layouts with CSS Grid and master advanced state-based animations. Coordinating these cascading systems allows you to transform static text documents into dynamic, professional-grade web applications.